All right, so here you're actually going to be loading wafers into a quartz boat. All right, and there is a standard operating procedure to it. That I'll explain in a second. All right. Now, when you practice this, yes, you can kind of do it at a distance, like I'm doing. But when you're first doing it, you're kind of, you have to kind of get in there. And the thing is the reason why we do this is that if you've never done this before, you're going to get very nervous. And I have wafers that cost $5,000 worth of processing before lab even starts. So students get very nervous, and then they drop it. I don't want that to happen with the expensive wafers. But if you drop wafers today, it's okay. Now, why am I loading these wafers into a quartz boat? Well, in order to process anything, we need to use temperatures above 800 degrees Celsius. And so quartz is a material that can handle that, right? We also have, on these particular wafers, we have a flat and we have it pointing up. And we load from the back forward, and we have, well, some wafers are shiny on both ends. I tend to buy the ones that are shiny only on one side because they're a little bit cheaper and I don't need it. But the shiny side faces this way because when we put it into the furnace, the flow of gas will come this way, and if it's facing the other way, things like the oxide thickness won't be evenly distributed, right? You'll be thick in one area and thin in others. There's still it's never perfect. You have to measure it. But the other thing is you're trying to track what's going on, and so when we do these wafers in lab, you give it a number, and so it's always in the, 1 is always there, 2 is always there. The flat is always up, shiny is always that way. So if we're analyzing it, and we're like, it seems, the oxide thickness is always thicker on top, or it's always thicker the farther you go this way. If we don't have a standard operating procedure, we don't know how to improve things. All right. Now this particular bow isn't our standard bow. All right. You're going to be transferring wafers from one of these to one of those, and you just have to do 5 wafers, right? And then the next person can move the 5 wafers back and back and forth, back and forth. And you just have the tweezers. But it's vital to make sure that we get the same results every time, or to do process analysis. Where's my industrial systems? You, right? Yeah. Right. So if I give her garbage, she's going to give me garbage. It'll look nice. It'll be done in Python, and we can run an AI plot on it, and but it's meaningless unless we do our job. So yeah, the quartz is for high temperature, flat up and shiny side, and then we do every other to let the gases go through. All right. Now somebody asked, why don't we have spring-loaded tweezers? The truth of the matter is I forgot they existed, and I don't seem to need them. We also have vacuum tweezers, but we don't really need that for today. All right. But yeah, that's it for this activity.